the one thing to say is that this crew represents the top of a big apex, a team that did a super job in the 51D mission. Just to make sure everyone knows who's who here, I'm going to start down at the far end. Jake Garn from the U.S. Senate, and you notice I don't call him Senator Garn, he's Jake to us, and he wouldn't have it any other way. Charlie Walker from McDonnell Douglas, payload specialist, and Dave Griggs, one of our MSs, Jeff Hoffman, an MS, Ray Seddon, an MS, erstwhile Don Williams, our PLT, and then our commander, Bo Bobkill, and I'm going to turn it over to Bo right now.
This was our patch. It was the fourth try at a patch since our mission had been changed so many times. Of course, this is always a very exciting time. It's the night before the launch when everything is rolled out on a pad and ready. And here we are before Don coming out, Don and myself, Ray and Jeff, Charlie and Dave and Jake. We were all very anxious. Of course, we had a number of delays, but the moment of truth was quickly arriving. We thought we weren't going to fly because of the weather, but they said, let's go. And here you can see the start sequence of the main engine, the hydrogen igniters spewing flame across behind the engines, and then them starting one at a time. Finally, they're up to speed, they're stabilized, and the solid rocket motors ignite. When the solid rocket motors ignite, you know you're on your way. You know where you're going, where they want you to go, and hope they're pointed in the right direction. It rumbles quite a bit while you're coming off of the pad. There's quite a bit of reflection off of the ground and off of the pad. Once you get up above the tower, the roll starts and things calm down a little bit, but there's still quite a bit of rattle and noise as you're going up through the atmosphere. You have to remember, when you go through 19,000 feet, you're already doing Mach 1. We went to the clouds about 10 or 12,000 feet. We didn't see any moisture, which was what caused the delay, but it was a solid cloud up to about 33 or 34,000 feet. Once we got off of the solid rocket motors, things smoothed down as we were on the main engines, and it was a smooth ride up from there on into orbit. Of course, once we got into orbit, we had the direct insertion, so we didn't do an OMS 1 for quite some time. We were able to see the tank and see it spinning off a mile or so from us. Let me turn it off to Jeff here.
The mission started normally enough with PAM deployment. We've deployed a lot of PAMs in the shuttle program, but it was sure exciting deploying our own. It's a beautiful sight watching it come across right on the Earth's horizon. It's, of course, spinning for gyroscopic stability, and it's just a beautiful sight as it slowly drifts away from us out over the horizon. And you can see the solid rocket motor underneath it, which ignited 45 minutes after deployment and raised the apogee to 22,000 miles, and that satellite's now successfully in geosynchronous orbit. Our second satellite, again, started out normally enough. It's the SYNCOM, the third one that NASA has launched. It's a lovely sight seeing it come out sideways like a sort of Frisbee deployment. You see that white antenna on the top. That's the omnidirectional antenna, which we expected to see come to a standing position about 1 minute and 20 seconds after the deployment. That's certainly the way it always happened in the simulator, but SimSoup had another idea this time, and well, after about 2 minutes, it finally sunk into us that it wasn't going to move, and of course we gave the call down to the ground. We then followed it. The other thing that should happen is that the satellite should spin up from its 2 RPM motion. After we deploy, then we burn our own engines, and from the 0G, the 1/10 of a G acceleration really gets your attention. Here's the ohms cutoff, and you can see all of the flaming coming around. I'm going to turn it over to Jake Garn now.
Now we're simply drifting away from the satellite. This is Ray doing her echo sounding, taking her blood pressure at this point while being restrained to the locker so she doesn't float off to some faraway place. And this is simply me, guinea pig, barfing Jake Garn with a few electrodes. I just want you to note that I was a perfect subject for the electroencephalogram. The top of my head, if I'd had hair, I couldn't have accomplished that particular task. And that amplifier floating there was no problem whatsoever. Here's Ray.
This is the American flight echocardiograph put together by some of our fine folks here at JSC. First American echo done in space. The transducer that I've got on my chest emits sound waves that are reflected back into the transducer, and they generate a two-dimensional picture of my heart on the screen. The system worked very well, and we got some excellent pictures of the heart. Here is a picture of my heart. The little flapping thing in the middle is the mitral valve on the left side of my heart, and my heart chamber is pumping blood, and we were looking at volume changes in the heart and differences in resistance in the peripheral blood vessels.
Here's some scenes from the operation of the electrophoresis equipment on board. In addition to letting the machine do its thing, which it did very well this time, I conducted some tests on samples of fluid from the device. And here I'm transferring some fluid from container to container and finally to a sample tray where I could read the results. The operations sometimes are a little hard when you've got to use both hands and you've got no feet on the floor. But the operations went well. The device and the tests all worked very well. As a matter of fact, we had the electrophoresis equipment operated as a clean machine this time, both electromechanically and biologically. I even performed some standard operations in calibrating flow rates through the machine at the sample pump, which you see me doing here. You know, just a normal orientation for these kinds of operations.
Well, it's constantly fascinating just to watch the way objects behave in zero gravity. Here we have a set of gyro-stabilized binoculars. There was a little bit too much friction in them, so they were actually a bit gyro-unstabilized. But still, with 14-power binoculars, it was just amazing what we could see on the ground. And, of course, I also enjoyed what I could see up in the sky, since I'm an astronomer. We also carried some science demonstration objects, commonly known as TOYS. This was done primarily to make some educational footage, which we can use and distribute to science teachers throughout the country. Here, Bo forgot to spin the gyroscope up, and somehow it just didn't stay stable. So we're going to give him another chance, and here he's going to get it spinning. There we go. Of course, the principle of gyroscopic stability has been around a long time. We use it for navigation. Our satellites use it when they come out of the cargo bay. But of course, without gravity and just being able to float it free here, you can study the behavior of the gyroscope and watch the way it moves around in a way that we never get a chance to do in laboratories on the Earth. I'm sure all of you have held a gyroscope on a string or on your fingers, and after a while, as it spins down, the force of gravity starts to torque it, and it starts to precess around. Of course, that never happens in zero gravity. You can keep playing with it almost up to the moment where it is not spinning at all, and it still stays stable. In fact, it was just a constant source of fascination, all the different things you could do with these very ordinary devices. This is a little magnetic wheel that I'm using. Normally on the Earth you start this with gravity. I found it was pretty easy to start it up using centrifugal force. This one, as long as I was holding it, behaved pretty much the way it did on the Earth. But as soon as you let it go, then it does all sorts of neat things. And here comes Mr. Yo-Yo. I've had a lot of discussions with physicist friends of mine about whether the yo-yo was going to work. And it worked fabulous. You could do it fast, you could do it slow, you could do it to the ceiling. That's the famous oi-oi. Dave did flying saucers around the moon. He's a real champ, and if they don't let him into the Yo-Yo Association of America, there's just no justice in the world. Putting the jacks here, there was constant constant danger of massive explosions if the ball came back in the wrong place. We managed to go through without ever losing the jacks, and although it's not on film, Ray did manage to do her 12sies by the end of the flight. If you let a paper airplane just float, it's pretty much carried away by the air currents in the shuttle, as you see here. And so it really doesn't take very much force just to start it on the most beautiful flight that you've ever seen of any paper glider.
Hope you like our home movies so far. The paddle ball behaved a lot like it does on Earth in that you can paddle it in nearly any direction if you're clever enough. I'm not sure I am clever enough to keep it going in each direction. And as you can see here, so the ins and outs, ups and downs were about the same. It's a little harder to do, let's see, to do this trick on Earth. The straightforward sort of paddle ball operation is much slower, and it's much easier. This one is a little tougher. Jeff has here some magnetic marbles. I'm not sure how you shoot marbles in space because it's a little hard to keep them in that ring. But your shooter seems to work fine. It joins right up with them all, and it forms into a toroid, as you might expect, with the magnetic lines and the magnetism that's inherent in the marbles. If you watch carefully now, on not this one, but the one after this, as Jeff sails the marble past after he repositions his ring here with its little tail, and relative to the horizontal lines on the bulkhead behind him, watch what this marble does. See it curve upward as the magnetic lines of force pass by the others. And here's our unofficial mascot. You might say he flipped out over this. Rat stuff really had it. The slinky, without the sag that you have to contend with in 1G, behaved pretty much the same as it does in 1G. You can start to see that, of course, they've set up a sine wave oscillation here, which continues to be reflected back and forth, and now a double one or perhaps a triple. And perhaps within there you can also see the standing waves reflected back and forth. The centrifugal force, of course, keeps this little car going around its track. On Earth, when it gets to the top, it would, of course, fall out. In space, what do you expect it's going to do? Well, with a little help from the doctor, sure enough,
I saw that.
it falls out.
This is fly swatter ops. The ground had decided at this point in time that we were going to re-rendezvous with CENTCOM and attempt to activate the separation switch with some of our homemade devices. This is the one that we call the fly swatter. It was made from a metallic swizzle stick reach mechanism that we had on board and some plastic book covers and gray tape. The ground gave us specific instructions on how to build it, what size it should be, and here Jake is helping me put some stitching into it to hold it together. The other one was called the lacrosse stick. It was a different sort of device.
Here we are on day 5, the regular day of our entry, had we maintained our normal activity plan.
You can't put your pants on 2 legs at a time.
That's Jeff putting on a lower torso assembly. It's a rather cumbersome task to get yourself suited up. EVA activity is a rather messy task to begin with. It really ties up the middeck. You can see all the different pieces of equipment we have laying around. Back in the background there is Charlie Cephas Walker giving Jeff a hand. We had reduced the cabin pressure down to 10.2 at this point. We did that on day 4 to denitrogenate Jeff's and my blood. Here we are with our lacrosse stick and the fly swatter. We kept close grasps on those because we certainly needed them to do the activity we intended to do later on. Didn't want to leave them outside the airlock when we depressed. There's Bo assisting me getting suited up there, getting the lower torso assembly attached to the hard upper torso. And here's Jeff popping up into the hard upper torso. Very crowded in the airlock. It's a small airlock. You can see me hanging on the right and Bo ricocheting back and forth between both Jeff and myself. Here we are shortly before fastening the upper torso to the lower torso assembly. We're hanging there making some last-minute adjustments. Ray's getting our picture. We're close to the point where we're going to be closing up the airlock and saying goodbye to the rest of the crew. Fully suited now, making some last-minute adjustments on gloves, glove fit, making sure that we have all the equipment that's required for the EVA. And momentarily we're going to be outside after we depress for the airlock down to 0 and open up the outer hatch. Ray had precisely positioned the remote manipulating system and its end effector right along the starboard longeron there. Convenient place. Jeff was able to tether himself on the outboard side to give himself some stability for work, and I tethered myself on the inboard side. And each of us, 180 degrees apart, started the work of putting the two devices, the lacrosse stick and the fly swatter, affixing them to the end effector. Here's a view from the sea camera. In the very near foreground, you can see the lacrosse stick still tethered to the longeron. And what we're working on right now is actually putting the fly swatter in at the 12 o'clock position with respect to the end effector. We tightened the two devices down with a device that's most familiar to folks here on here on Earth is more like a come-along device.
You can see me moving it up and down there to actually take up the slack of the system.
The total EVA ran about 3 hours and 6 minutes and a few seconds. Most of the work activity of putting the two devices onto the end effector was accomplished within the first hour, slightly over an hour. We then, at the completion of that, had to move the arm over back to its manipulating position mechanisms, place the arm back down into those mechanisms, and roll the arm inboard as if we were going to stow and make a re-entry. The purpose for that being that we weren't really sure whether the fly swatter or the lacrosse stick might impinge upon the doors and prevent them being closed. We did roll the arm in afterwards, check the clearance, and there was some interference between the lacrosse stick and one of the cameras, but the interference was slight, and we had no problems with interference with the doors and the potential for not being able to close the doors for entry. Another view from the sea camera, you can see now that we've got the fly swatter on at the 12 o'clock position, and we're getting the lacrosse stick fixed in at the 9 o'clock position from Yearville Point. Jeff, you want to say a couple words here, maybe?
Well, we did all of our actual work during the day because Houston wanted to be able to see what we were doing. If you heard the conversations, you'll realize that we certainly were not on our own out there. We were talking very closely with people inside the cabin and with the people on the ground, and it was a massive effort that went into doing this. It did mean, of course, that when we went past the Terminator and it got dark in the bay, the ground just asked us to just sort of hang on and, well, watch the world go by. And I think those were some of the most memorable moments of my life. The feeling when you're just hanging on to the side of the orbiter, not working too hard, not exerting any force. I felt myself almost decoupled from the spaceship and became for a few really beautiful moments just a human satellite floating around.
Here's Ray back inside, repositioning the arm, and the finale, a beautiful shot of Jeff working himself forward on the starboard longeron. I'm concurrently working myself forward on the port. At the end of the EVA, we're back to putting our tools back into the chest that we have out in the payload bay for them, and they're re-entering the airlock. And from that point, we've done everything we can, and we turn it back over to Don and Bo, who are going to effect the rendezvous.
Now we had to go to work with the rendezvous targeting, none of which we had on board. As far as the procedures, the flight data file, and the inputs we need to do this, so we all came up by teleprinter, perhaps one of the longest teleprinter messages in the space program. But we made ourselves a book and with a little Scotch tape and a lot of cutting and pasting, and got the rendezvous procedures together. This is a camera zoom in on the SYNCOM as we were approaching it from underneath and coming up onto the velocity vector of the satellite. You can see it rotating here at about 2 RPM. You're looking at the bottom end of it. After we're established into a tracking position, Bo moved back to the aft station where he's standing on the starboard side now and flying the spacecraft from there. And that's where all rendezvous and proximity ops are flown in the spacecraft, generally standing in the back, hovering in the back, if you will, looking out through the overhead window using the hand controllers, the rotational and translational hand controllers that are in the back of the spacecraft. As it comes around here, we'll be able to show you this arming lever before we took a swat at it. Bo is looking. Here it comes now in that orange rectangle in the lower right-hand corner of it. You see what the lever looked like when we first saw it. And then Ray got ready to take a swipe at it.
I guess there was some question about whether the arm could be used in this manner with some rather primitive tools on the end of it to hit that lever and see if we could activate the separation switches by it. You'll watch the lacrosse stick on this first pass. You'll see it come in, and I'll get your opinion on whether you think we got it or not. Here it comes in. Grabbed it, pulled it. Real good pull. First time, went in with a fly swatter the second time, tried to hook it on one of the rungs of the ladder. Here we come again, grabbed it. That's number 2. This time we try and hit it with the base of the cone, which is a more solid object. Get it one more time. That's 3. We got, we can count at least 3 really good whacks at it. At this point in time, the window closed that we were supposed to be hitting this thing, and since we had made hard contact with it, we had to back off from it at this point in case it was going to activate itself sometime later.
Bo flew the initial sep burn from the back, which was in a Z orbiter direction. And meanwhile, while he was doing that, I was targeting up a small out-of-plane burn to get us out of the plane of the spacecraft so we wouldn't come close to it on subsequent revolutions. And then 15 minutes later, we targeted an ohms burn to do the final separation. The reentry was a very exciting part of the flight for me, at least, because in a lot of it we were in this particular attitude, and I got to look out the window and see the ground going by. It goes by a lot faster when you're down below than it does up at orbital velocity. We rolled out coming over the central part of Florida here and into the Kennedy Space Center into a slight left bank prior to intercepting the heading alignment circle. We had gone just a little north of ground track, had corrected, and then come back to our nominal ground track. You can see the speed brake opening here to control the energy and rate of descent of the spacecraft. And of course, we're a glider here at slightly under 200,000 pounds, as on all previous flights. It's a beautiful day in Florida. The sun was shining. There were a few scattered clouds down over Melbourne. Kennedy Space Center itself was clear. I had a great view as we came around the heading alignment turn on the final for runway 33 at the Cape. I was talking to Bo all the way around the turn relative to lineup and glide slope and energy management, and he was doing a great job of flying the airplane right around there. As we roll out on final here, I'll let him describe the landing.
As you know, we were waved off once. We didn't think we were coming in because seldom does the weather get better in Florida when it's cloudy in the morning, but it did. It was beautiful. Here we were coming right down near the runway and started our pull-out for the final landing. Here we're coming over the Banana Creek, and in just a second you'll see the gear come down, and finally the overrun of the runway come up. There was a right crosswind. We touched down just a little bit to the left of the center line and drifted a little bit farther to the left with the crosswind. I put in a correction and brought it back to the center line. It handled beautifully. We rolled out with just the moderate braking and stopped with about 3,000 feet to go. We probably could have stopped a lot shorter if I had used a lot harder braking. At that point, we were all elated. We felt that we were really home. I mean, we had gone through this mission. We had done all of these things. Here we were rolling out. It was certainly under control. We were ready to stop and see our families and come home. What else could possibly go wrong? We, a few seconds later, felt one of the wheel brakes lock up, and it was no problem to control the vehicle. I mean, it was absolutely under control. There was no question about it, and you can see that. It didn't diverge at all. And then just about the time we came to a stop, the right tire blew. I think you'll see when we come down the ladders that there are broad smiles on everyone's face. And it was a demanding, challenging, extremely exciting, and of course, spaceflight is always beautiful. We're all looking forward to our next flight. Quite a few of us have them assigned right now, and we can't hardly wait. Thank you very much.